All right, question number 9 says an object is dropped from a tower 256 feet above the ground. The object's height above the ground, t seconds after it is dropped, is equal to s of t, which is 256 minus 16t squared. We want to determine the velocity and acceleration the moment the object reaches the ground. All right. So we're going to start with our equation, s of t. All right, to find the velocity, we're going to find the first derivative. First derivative, this derivative of a constant is 0. 16 times 2, or negative 16 times 2 will give me a negative 32 t. You subtract 1. Second derivative, which is going to be s double prime. This is going to give me the acceleration function. Derivative of this will just be negative 32. Okay, so now we have the functions. We need to find out when this object hits the ground, and we can plug that in for t. So in order to find when it hits the ground, we're going to set this equal to 0. So I'm going to say 256 minus 16t squared equals 0. Okay, running off a little bit. We're going to move the 16 over by adding it. So we have 256 equals 16t squared. Divide by 16. 16. I think 16 times 16 is 256. Brain getting fuzzy. Let's just double check. Yep. 16, 16, 256. Okay, so divide by 16, we get 16 equals t squared. And then we got to take the square root. We get plus or minus 4 equals t. Since t is time, we ignore negative time, and t would be 4 seconds. So 4 seconds after this object is in motion, it hits the ground, we're going to plug the 4 into the velocity function. And that will give us negative 32 times 4, which will give us a negative 128. And then if we plug that into the acceleration function, there's nowhere to plug it in. We still just end up with a negative 32. Units, object dropped from a tower, height, t seconds. It doesn't give me units, but it says it feet. I'm just trying to look. We got 256 feet, t seconds. Okay, so velocity feet per second, and this is feet per second squared as far as your units. Velocity when it hits the ground, and the acceleration